All right, lesson 1 of unit 2 is about Radian measure. So first of all, learning goals for today. After today's lesson, you should be able to understand the definition of radian measure, convert between degree and radian measures, understand the definition of trigonometric ratios into the Cartesian plane, evaluate exact trigonometric ratios of special angles, and solve real-world problems involving trigonometric ratios. Okay, so first of all, let's have a look at the definition of radian measure. The radian measure of angle theta is defined as the length A of the arc that subtends the angle divided by the radius R of the circle. That is theta equals A over R. Do you understand? This is a definition of radian measure. So for example, if the length of the arc A equals 5 meters and R here equals 2 meters, theta in radian measure is then 5 meters over 2 meters, which is 2.5 radians. Understand? Okay, so let's have a look at how we convert between degree and radian measures. So suppose angle theta measures d degrees and r radians. Then according to the definition of the radian measure, we have the following relationship. Okay, so first of all, if we want to convert the radian measure to degree measures, if you want to convert degree measures to radian measures, the radian measure equals A over R, right? So if we have theta in degrees D, first of all, we know that the ratio between D and the 360 is actually the ratio that corresponds to 2 pi R, right? This is the length of the arc, and the ratio between this arc and the radius R is defined as a radian, right? So R equals D times pi over 180. In this way, we can convert the degrees to the corresponding radians, right? And if you want to convert the radians to degrees, you can just multiply both sides using 180 and divide both sides using a pi. So that means D is R times 180 over pi, right? So please write this down to your notebook, because in the following examples, we're going to use this a lot, okay? Radian measure equals degree measure times pi over 180. And degree measures equals radian measures times 180 over pi. Okay, any questions? All right, so let's have a look at some examples. First of all, if the degree is 90 degree, okay, theta is 90 degree. Of course, 90 degree corresponds to an arc of 1/4 of the length of the whole arc, which is the length of the whole circle, right? Which is pi r over 2, right? And theta in radian measure is the length of the arc over radius r, which is pi over 2, right? Which is half of pi. So 90 degree is half of pi. Understand? So similarly, for 180 degrees, the theta in radian measure is pi. And if theta is 360 degrees, the radian measure is 2 pi. Okay, and here is a list of commonly used angles in radians. So for example, we have already discussed this one. This one. And 180, this one here. And also we know that 360 is 2 pi, right? It's better for you to get familiar with these conversions, which will make your calculations quicker, okay? Please have a look at them after this class. Okay, so now let's have a look at a practice. Determine an exact and approximate radian measure to the nearest hundredth for an angle of 50 degrees. So it asks you to convert the degree measures to radian measures. Okay, I'll give you 3 minutes to think about this question. All right, let's have a look at the solutions. So according to the conversion formula, the corresponding radian measure is 180 over 50, right? And then multiplied by a pi. So this is our radian measure for the degree of 50, which is, made a mistake here. According to the formula, the radian measure is 50 over 180 pi, right? Which is 5 over 18 pi. And this is an exact radian measure. The approximate radian measure is, this is approximately 5 by 3.1415 over 18, which is approximately 0.87 radians. Okay, so as long as there is no specific statements, whenever possible, you should leave angle measures in exact form. Okay, so always try to leave your result in the exact form to preserve accuracy. Okay, you can also check the solutions after the class in this lecture slides. All right, let's have a look at another practice. Determine an exact and approximate degree measure to the nearest tenth for an angle of 3 radians. Okay, so this time we need to convert the radian measure to a degree measure. Okay, again, I'll give you 3 minutes to think about it. All right, let's have a look at how we can do this. Okay, you can use a conversion equation to convert the radian measure to degree measure, right? So this time we have 3 radians. So degree measure equals 3 radians over pi times 180, which is 540 over pi, right? And this is a exact measure. And the approximate measure is 540 over 1.1415, which is approximately 171.9 degrees. Okay. And again, whenever possible, you should leave angle measures in exact form, which is here, to preserve accuracy. Okay, any questions? No? All right, so let's have a look at another practice. Suzette chooses a camel to ride on a carousel. The camel is located 9 meters from the center of the carousel. If the carousel turns through an angle of 5 pi over 6, determine the length of the arc traveled by the camel to the nearest tenth of a meter. Okay, I'll give you 3 minutes to think about it. Okay, any thoughts? Actually, we can sketch this problem in a graph, right? So suppose this is the center of the carousel and this is a camel, okay? And this camel turns around the center, right? And the radius of this circle is 9 meters. So R is 9, which is the distance between the center and the camel here, right? And it asks us to find the angle in radians here. When this camel turns through an angle of 5 pi over 6, it asks us to find the length of the arc. So we need to find the value of A here, right? Okay, according to the definition of radian measures, the radian measure theta in 5 pi over 6 is defined as the ratio between the arc and the R, right? So this means the length of A equals 5 pi times R over 6, which is 5 pi, R is 9, so 45 pi over 6, right? Which is 15 pi over 2. This is the exact expression, right? If you want to find the approximate measure, just put the value of pi here, and you will get the approximate result, which is about 23.6 meters, okay, to the nearest tenth of a meter. Okay, any questions? Okay, again, you can check the result, you can check the solutions in this slide after the class. All right, if you don't have any questions, let's have a look at the another practice. The angular velocity of a rotating object is the rate at which the central angle changes with respect to time. The hard disk in a personal computer rotates at 7,200 RPM. That means revolutions per minute. Determine its angular velocity in degrees per second and radians per second. Okay, I'll give you 2 minutes to complete this practice. All right, let's have a look at the solutions. So first question, 7,200 revolutions per minute, right? And we want to convert it to degrees per second. So 1 revolution equals 360 degrees, right? So 7,200 times 6, 360 degrees. And also we need to convert 1 minute to 60 seconds, right? So in this way, we'll get the speed in degrees per second, which is 43200 degrees per second, right? Next, radian per second. Again, let's start from 7,200 revolutions per minute. Again, 1 revolution is 2 pi, right? So 1 minute is 60 seconds. All right, so in this way, we'll get 240 pi radian per seconds. Okay, any questions? No? Okay, let's have a look at the third part of today's class. Okay, the next key point is how do we define trigonometric ratios in a right triangle? So this is a review of the definition of the trigonometric ratios in right triangle. Probably you have already studied, you have already learned this, right? Okay, so if we have a right triangle here and we denote the angle here as t. Sine t is defined as the opposite side over the hypotenuse side, right? And cosine t is defined as adjacent over hypotenuse. And tangent t is defined as opposite over adjacent. And cotangent t is the reciprocal of tangent t, which is adjacent over opposite. And secant t is defined as the reciprocal of cosine t. And cosecant t is defined as the reciprocal of sine t, right? And sine t, cosine t, tangent t are called primary trigonometric ratios because the other 3 trigonometric ratios can be obtained by looking at the primary ratios here, okay? So if you want to remember this, you can always remember these 3 trigonometric ratios. And if you want to use the other 3, you can just manually evaluate. Okay, again, there is a Pythagorean theorem in the right triangles, which states that the opposite square plus adjacent square equals hypotenuse square. Understand? Okay, so next, let's expand this concept a little further, which now we can define the trigonometric ratios in a 2D Cartesian plane. So first, before we proceed to the definition in 2D Cartesian plane, let's review the notation of angle in 2D Cartesian plane first. So in a 2D Cartesian plane, we can have a positive angle or a negative angle, right? For positive angles on the coordinate plane are angles that go in counterclockwise direction. So for example, here, this is initial side, which is usually on the positive side of x-axis, right? And this is the terminal side. If this angle turns in counterclockwise, then it is a positive angle. For example, the angle here is 135 degrees, or 3/4 pi. On the other hand, negative angles on the coordinate plane are angles that go in clockwise direction. So for example, if the initial side is the positive direction of x-axis and it turns clockwise to the terminal side here, and this angle is a negative angle. For example, this angle here is minus 225 degrees, or minus 5 pi over 4. Understand? So now we are clear what is a positive angle and what is a negative angle. Next, let's have a look at how we define trigonometric ratios in a 2D Cartesian plane. So suppose we have an angle in the 2D Cartesian plane. This is the initial side, and this is the terminal side. You can find any point on the terminal side except the original point. And we denote the distance between this point to the original point as r. R is distance, right? So r is always positive. And the coordinates of P is X and Y. Then the definition of trigonometric ratios is as follows. Okay, suppose we denote the angle as alpha. Then sine alpha is Y over R, which is a Y coordinate over the distance R. Cosine alpha is X over R. X is X coordinate of the point P over the distance R. Tangent theta is defined as Y over X, where Y is a Y coordinate, X is a X coordinate. These are the primary trigonometric ratios. And for the secondary trigonometric ratios, you can find them using the reciprocal of the primary trigonometric ratios. Understand? Cosecant, for example, cosecant alpha is R over Y. Secant alpha is R over X, and cotangent alpha is X over Y. Understand? Okay, so in this way, we can also use the unit circle method, which means, for example, this is an angle theta here. This time we draw a unit circle. This is a unit circle. What is a unit circle? Unit circle has a radius of unit 1. Understand? And there's an intersection point between the terminal side of this angle and the unit circle, right? We denote this point as PXY. Then we know that the distance between this point and the origin point is 1, right? Because this is a unit circle. Unit circle has a radius of 1. Okay, in this way, sine theta equals Y over R, right? This is according to the definition. And this time R equals 1, so sine theta is just Y, right? So we can rewrite, actually we can rewrite the point here. The Y coordinate is sine theta. And we also know that cosine theta is X over R, right? And R here is 1, so cosine theta is X. So X, the X coordinate X is actually cosine theta. Okay, so we know that the intersection between the terminal side and the unit circle is cosine theta, sine theta. These are the coordinates of the intersection point P here, right? And tangent theta is Y over X, which is the Y coordinate over X coordinate. Okay, and for the other trigonometric ratios, you can always find them using the reciprocal of the primary trigonometric ratios. Any questions? No? Okay, let's have a look at an example. Determine exact values of the 6 trigonometric ratios for an angle of 3 pi over 4. Okay, I'll give you 1 minute to think about this. All right, let's have a look at the solutions. Okay, first of all, let's find this angle in the 2D Cartesian plane. So if you're not very familiar with the radian measure, you can convert it into degree measures, right? Pi is 180 degrees, so 3/4 of 180 is 135 degrees, right? So this angle is here. The initial side is here and the terminal side is here. And according to the definition, we can use a unit circle method to find its 6 trigonometric ratios, right? And then we draw a unit circle here. The unit circle always has a radius of 1 unit, right? And there is an intersection point here. We can denote it as P. And let's denote its X and Y coordinates as X and Y. So according to the definition, sine 3 pi over 4 is the Y coordinate of P over R. R is 1, right? So it equals Y. And we also know that in this small right triangle here, this degree is 45, right? So if the length is 1 here, we can find the length here and here, right? Okay, so that means x squared plus x squared equals 1, according to the Pythagorean theorem, right? 2x equals 1, so x equals positive or negative square root of 2 over 2, right? So because this terminal side is in the second quadrant, so that means the x coordinate is minus square root of 2 over 2, and the y coordinate, which is x, is positive square root of 2 over 2, right? So y is square root of 2 over 2. Okay, so this is a sine 3 pi over 4, right? Okay, next, cosine 3 pi over 4 is, according to the definition, is the x coordinate over r. R is 1, right? Which is x. And we have already calculated the x coordinate of p is minus square root of 2 over 2, right? And tangent 3 pi over 4 is defined as y over x, which is square root of 2 over 2 and then divided by minus square root of 2 over 2, which is minus 1, right? Okay, so these are the primary trigonometric ratios. And then we can find the secondary trigonometric ratios by using the reciprocals of the primary trigonometric ratios, right? You can either find them using definition or using the reciprocals of the primary trigonometric ratios. Okay, so first of all, let's have a look at cosecant 3 pi over 4. This is the reciprocal of sine 3 pi over 4, which is square root of 2, right? And secant 3 pi over 4 is the reciprocal of cosine 3 pi over 4, which is minus square root of 2. And cotangent 3 pi over 4 is the reciprocal of tangent 3 pi over 4, which is minus 1. Okay, any questions? You can also check the solutions in this lecture slides, okay? All right, if you don't have any questions, let's have a look at the cast rule. The cast rule says that in quadrant 1, all 3 of the sine, cosine, tangent theta are positive. So we put a O. A stands for all here. All of the primary trigonometric ratios are positive in the first quadrant. And in the second quadrant, only sine is positive, right? Well, cosine, tangent theta are negative. And in the third quadrant, only tangent theta is positive. Why? Because sine theta here is y over r and cosine theta here is x over r, right? So in the third quadrant, both x and y coordinates are negative and r is always positive. So in this quadrant, sine is negative, cosine is negative, only tangent is positive, right? Because tangent theta is y over x. Y is positive, y is negative, x is negative, so tangent theta is positive. Okay, so similarly in the fourth quadrant, only cosine theta is positive. This is called a CAST rule, right? C-A-S-T, CAST rule. That will help you to decide the signs of the primary trigonometric ratios. Okay, please remember these rules because it's very useful in our future study. Okay, next let's have a look at trigonometric ratios of some special angles. Okay, please have a look at this graph. This graph basically tells us the three trigonometric ratios of some special angles. First, for example, the first value here is a cosine, which is related to the x coordinates. The second coordinate here is sine, and the third number here is tangent. For example, sine pi over 6 is square root of 3 over 2. And sine pi over 6 is 1 over 2, right? And cosine pi over 6 is square root of 3 over 2. And tangent pi over 6 is square root of 3 over 3. Okay, actually you can evaluate all these values using a unit circle. Okay, I'm not gonna do this for you. Please have a look at these, as it is very helpful when we evaluate the trigonometric ratios of some special angles. Okay, and there is a little trick to quickly use this graph. So for example, if I want you to calculate sine 3 pi over 4, that means the angle here. So how do you calculate this quickly? We are familiar with the value in the first quadrant, right? So you can just use property of symmetry. Find the corresponding angle here. These two lines are symmetric about y-axis, right? So calculate this first. And then this angle has the same sine values with this angle, right? Because their y coordinates are the same. Understand? Okay, so now let's make a practice here. Evaluate cosecant 7 pi over 6. Okay, I'll give you 2 minutes to think about it. All right, let's have a look at the solutions. So this is secondary trigonometric ratios, right? So we can calculate its ratios according to the corresponding primary ratios. So cosecant is the reciprocal of sine, right? So we need to consider what is sine 7 pi over 6. So note 7 pi over 6 is actually pi plus pi over 6, right? So where is pi over 6? Pi over 6 is about 30 degrees, which is here. This is our pi over 6, right? Pi plus pi over 6. Pi is 100 degrees. This means we turn this angle, turn its terminal side to another 180 degrees, which comes here, right? This is 7 pi over 6. And this terminal side has point symmetry with this side, right? And if you pick a point here, denoted as P, which has coordinates as X and Y, then if you turn 180 degrees, P comes here, which is P prime, right? And X coordinate becomes minus X. Y coordinate becomes minus Y, because everything is converted to negative, right? If you turn 180 degrees. Okay, so if the original sine alpha is y over r is distance, right? Then when you turn 180 degrees, the new theta here, sine theta prime, becomes minus y over r, right? Because currently the y coordinate becomes minus y here, right? So first of all, we can calculate sine pi over 6. This is easy, right? Because sine 30 degrees is 1 over 2. And then we know that sine 7 pi over 6 is just the negative side of sine theta, right? So negative 1 over 2. This is what we want here, right? Okay, so now we can make the conclusion. Cosecant 7 pi over 6 equals 1 over minus 1 over 2, which is minus 2, right? Okay, any questions? Okay, so let's have a look at another practice. Ravender is flying his kite at the end of 50-meter string. The sun is directly overhead. The string makes an angle of 1/6 pi with the ground. The wind speed increases and the kite flies higher until the string makes an angle of 1/3 of pi with the ground. A, determine an exact expression for the horizontal distance that the shadow of the kite moves between the two positions of the kite. B, determine the distance in part A to the nearest tenth of a meter. Okay, I'll give you 3 minutes to complete this practice. All right, let's have a look at the solutions together. Okay, we can illustrate this problem in the following graph. So first of all, the kite is at position 1, right? The angle between its position and the horizontal axis x is 1/6 of pi, right? So when the wind speed increases, it comes to a position of 2, and the angle with ground becomes 1/3 of pi, right? Okay, so at position 1, we have the following relationship. According to the definition of cosine, 1/6 of pi is x over r, right? X is the x coordinate of P1. Let's call it x1. So x1 over r is 50 meters, right? R is simply the distance between the position 1 and the original point here, origin point here. So according to this relationship, we know that cosine pi over 6, according to the special angle, according to this graph of the special angles, you can find that cosine 1/6 of pi is square root of 3 over 2, right? This is why you need to get familiar with the trigonometric ratios of the special angles. This equals x1 over 50. So x1 equals 50 times square root of 3 over 2, which is 25 times square root of 3, right? Okay, at position 2, similarly, we can have the following relationship. Now the angle becomes pi over 3. So cosine 1/3 of pi equals, according to the definition, is x coordinate, which is x2, over r. R is 50, right? Okay, so from this relationship, we know that x2 is 50 over 2, which is 25. So the distance d is x1 minus x2, right? Which is 25 square root of 3 minus 25, which is 25 times the difference between square root of 3 and 1. If you want to find the approximate value, you can just use the approximate value of square root of 3, which is 1.732, right? Okay. And the approximate value is 18.3. Okay, any questions? No? All right, so let's make a summary of what we have learned today. So after this class, now you should now be able to understand the definition of radian measure. So the radian measure theta is actually a ratio between the arc and the radius, right? Convert between degree and radian measure. So radian measure is degree measure over 180 times pi, right? And degree measure is is radian measure over pi times 180. Understand the definition of trigonometric ratios in 2D Cartesian plane. So in 2D Cartesian plane, for any angle theta, the trigonometric ratios is defined as, first of all, we can find any point on this terminal side, right? And for example, sine theta is then defined as y over r. R is distance between this point and the origin point. And cosine theta is defined as x over r, right? And tangent theta is defined as y over x, right? These three ratios are called primary trigonometric ratios. And you can find the secondary trigonometric ratios using the reciprocals, right? Okay, and next, evaluate exact trigonometric ratios of special angles. For example, we know that sine 1/6 pi, we have already know that primary trigonometric ratios of 1/6 pi, right? And then 1/4 of pi, and then 1/3 of pi, right? And also 0 and 1/2 of pi. This is in the first quadrant, right? The trigonometric ratios in other quadrants can be determined using the line of symmetry or point symmetry, right? So you can evaluate all these special angles into the Cartesian plane. Okay, next. Then we shall also be able to solve real-world problems involving trigonometric ratios, such as the examples we have illustrated here, okay? All right, so this is all for today. I'll see you in next lesson.